Welcome to the deep dive, everybody. Today, we're going to look at a brand new paper
Oh, cool.
from the Quen team at Alibaba Group, and it's called The Lessons of Developing Process Reward Models in Mathematical Reasoning.
Catchy.
Yeah, it's a mouthful, but get ready because we're going to be talking about how AI is moving beyond just, solving problems in math
Right.
and actually beginning to think like mathematicians,
Yeah.
step by step.
It's an interesting shift. I mean, we always see like AI doing incredible things like playing games or recognizing images, but like mathematical reasoning, it's a whole other ball game.
Absolutely. Especially when you think about, what this means for like finance, healthcare, research, where the why an AI makes the decision is like almost as important as the decision itself.
It's the heart of the issue, right?
Right.
Because up until now, a lot of the success has been, brute force computation.
Right.
Like a student kind of just making lucky guesses on a test.
Totally.
They might get the right answer.
Yeah.
But the logic is completely off.
And that's where these process reward models or PRMs come in.
Yeah.
They're like an AI tutor that's evaluating each step in the AI's thought process, not just the final answer.
It's like having a teacher looking over your shoulder
totally.
as you're working through a problem and pointing out, a fallacy or an incorrect calculation, but it's not a human.
Right.
It's another AI that's been trained.
Yeah, that's wild. So how do they train these like AI tutors? Like I imagine it takes a ton of data to teach an AI how to like think like a mathematician.
You're absolutely right. And the researchers, they actually talk about how data annotation is one of the biggest hurdles in developing these effective PRMs. So imagine if you have to like provide a Library of Congress worth of annotated math problems where every single step is labeled right or wrong.
That's nuts.
It's a massive.
Yeah, I see why that would be a major bottleneck.
Absolutely.
So did they come up with any like creative solutions for this, like for the data part?
They did. They explored three approaches. Mainly,
Okay.
one is using this technique called Monte Carlo estimation.
Okay.
And essentially what they do is they have the AI solve a problem multiple times from each step.
Okay.
And then they use the success rate to judge how correct each step is.
So like they give it a bunch of practice problems and see if it can get to the right answer, like starting at different points.
Exactly.
Gotcha.
But as you can imagine, this has some limitations.
Yeah, I was just thinking that.
What if the AI is consistently making the same mistake?
Right.
Even if it's getting the right answer sometimes.
Totally.
It's like you're studying with someone.
Yeah.
And they keep making the same errors that you are.
Yeah, totally.
So the second approach they used was they actually use a more powerful large language model, an LLM,
Oh, okay.
to act as a judge.
So they're using AI to train AI.
Exactly.
That's crazy.
Yeah. So this LLM is evaluating each step of the solution logically and mathematically.
So it's like they have a world-renowned mathematician check the work.
Exactly.
Okay.
But, I mean, LLMs are still under development, and they have their own biases,
Yeah, of course.
So the gold standard is human annotation.
Right.
Having experts actually check the work.
Of course. But going back to that Library of Congress thing.
Oh, yeah.
Like to get humans to actually do that.
Yeah.
That would be so expensive and time-consuming.
It would be very expensive.
Yeah.
It's a lot.
Did they find like a middle ground?
They did. And this is where it gets really interesting.
Okay.
They call it consensus filtering. It combines the Monte Carlo estimation and the LLM as a judge.
So they're combining the two.
They're combining the two.
I like it.
Yeah.
So tell me more about that.
Basically, they filter the data, and they only keep the steps where both agree.
Oh, okay.
The Monte Carlo and the LLM judge.
And a second opinion from a doctor.
Exactly.
Yeah.
And it's a great way to leverage the strengths of each method while reducing that reliance on human annotation.
Did it work?
It did.
Oh, wow.
The Quen team found that they were able to achieve similar results to the LLM judge alone.
Wow.
But with way less data.
How much less?
60% less.
That's a lot.
That's huge.
That's awesome. So they found a way to make it like faster without
more efficient.
Yeah, without sacrificing the accuracy.
Exactly.
That's amazing. This is super fascinating. So what else did we learn about how they're evaluating these like process reward models?
So this is where the researchers really get into challenging the status quo.
Okay.
They argued that just looking at the final answer, it wasn't telling the whole story.
Right.
They argued that we need to go beyond answer-based and focus on the entire reasoning process.
Because the AI could, like, get to the answer the wrong way, like we talked about.
Exactly.
Yeah.
It could be through a series of bad steps or just lucky.
And we'd miss that.
And we'd miss that completely.
If we were just looking at the answer.
Exactly.
Yeah.
So this is where they introduce a benchmark called Process Bench.
Okay.
And this is designed to specifically test the PRM's ability to catch those errors in the steps, not the final answer.
So it's like a detective.
Yes.
Yeah.
Examining every piece of evidence.
Looking at every little thing.
At a crime scene, not just the obvious clues.
Wow. So they're like really raising the bar for what it means for an AI to like understand math.
They are.
My brain needs a second to process all of this. This is really fascinating stuff.
It's a lot.
I'm really starting to grasp like the nuances of training and evaluating these like AI tutors.
Yeah, it's really complex.
Yeah. So let's take a quick pause to gather our thoughts. And when we come back, we'll talk about some key takeaways. And I have a thought-provoking question for everybody.
Awesome. I can't wait.
So before the break, we were talking about this new research on process reward models, PRMs, and how researchers are using them to train AI to reason like mathematically.
Yeah, and we talked about like the whole data challenge involved in training these PRMs.
Right.
And how the researchers at the Kim team explored some interesting approaches to deal with that.
Right. They even developed that like hybrid approach or called consensus filtering to streamline the process.
Right.
But what really got me was their take on how PRMs are evaluated, like traditionally.
Oh, yeah. The best of N.
Yeah, best of N.
Evaluation method. It's really common in machine learning where you essentially have the AI generate, let's say N solutions.
Okay.
And you pick the best one.
Okay.
According to your metric.
So like in the context of these PRMs, you'd have the AI try and solve a math problem like over and over.
Yeah, a bunch of times.
And then the PRM would pick the solution that it thinks is best.
Yeah.
Logically.
Yeah, exactly.
But they found like some problems with this.
You did.
Right.
Yeah, because best of N can like sometimes hide flaws in the AI's reasoning.
Oh, okay.
And remember, the whole point of these PRMs is to look at the process, the step-by-step logic.
The steps.
Not just the answer.
Right, because an AI could get to the answer, like the right answer, but through like
a series of illogical steps.
A bunch of bad steps or like lucky guesses.
Yeah, exactly.
And if we only look at the best final answer, we miss all that.
We might think that the AI actually understands the math more than it actually does.
Oh, like a student getting like a lucky guess on a test.
Exactly. They got the right answer, but they don't get the concept.
They don't, yeah.
So what the researchers propose is to use like a more what they call holistic evaluation that looks at the whole reasoning process, not just the answer. And they're big on this combination of answer-based and step-based evaluation.
Okay, and that's where Process Bench comes in, right?
Yes.
So it's designed to really look at the PRM's ability to catch errors in those like middle steps, those like...
Yeah, the subtle errors.
The little tiny, like the calculation errors.
Exactly. It's like way more rigorous.
Yeah.
And it forces that PRM to look at every step.
Yeah.
Like a detective looking at every single piece of evidence.
Gotcha. So they're like upping the standards for AI to like really understand the math.
Yeah, they're not just looking for the answer. They're looking for like the right way to get there.
The logic, yeah.
Yeah.
So did they test their own PRMs using this like harder evaluation methods?
They did.
Okay.
And their PRMs actually outperformed other like open source alternatives at finding those errors.
Wow. So it seems like this like combo of like innovative training and this more intense evaluation.
Yeah, a more rigorous evaluation.
Yeah, it's paying off.
It is. And it's not just about like accuracy. It's about making the whole reasoning process more like transparent.
Right, because we have to be able to trust it.
We have to trust it.
Yeah.
Especially when you think about all the applications.
Especially with important stuff, yeah.
Absolutely.
I'm curious, did they like look at how different types of PRMs performed on this best of N? Like just...
Yeah, they did. And they found something interesting about the ones trained using that Monte Carlo estimation method.
Right, the one where the AI tries to solve the problem a bunch of times.
Yeah, from each step.
And then the PRM uses that success rate to be like, okay, this step's good, this step's bad.
Right.
Yeah.
They found that when these were kind of optimized for that best of N, they kind of overemphasized the final answer.
Wait, so they forgot about the steps?
Kind of, yeah. It's like they got so focused on getting the right answer that they forgot about the steps along the way.
Oh, that's ironic.
Yeah.
That's really interesting. So that's why they're pushing for going beyond this best of N thing and using these more like comprehensive ways of evaluating these PRMs.
Exactly. Looking at both the answer and the process.
I think we've covered a lot of ground here.
We have.
We've been talking about this for a while.
It's fascinating.
So let's take another quick pause and we'll come back and wrap this whole thing up with some key takeaways.
Okay.
And I've got a like thought-provoking question for everybody. Okay, so we're back and ready to like wrap up our deep dive into AI and math.
Yeah, we really went deep.
Oh, no, that's a lot.
Really explored like the whole world of training AI to reason like us.
Yeah, like real mathematicians.
Yeah.
So like if we were to like sum this whole thing up,
right,
what would you say are the biggest takeaways?
Well, I think the first one is like how important these process reward models are.
The PRMs.
Yeah, the PRMs, they're crucial for making sure that AI math reasoning is more than just,
like random guesses.
Yeah, lucky guesses.
Yeah.
Like they're like the tutors guiding the learning and checking every step.
Yeah, and we saw that like building those PRMs, that's a whole challenge in itself.
Yeah, it's not easy.
You need like mountains of data.
Yeah, it's a lot of data.
And the old ways of doing it are like so slow and expensive.
Very.
But the cool thing is like these researchers at Quinn, they're coming up with like new ways to deal with that.
Yeah, they're doing some cool stuff.
Like that consensus filtering thing, that sounds pretty groundbreaking.
Yeah, combining those two methods, it's really clever.
It's really smart.
And it really cuts down on the data they need.
Yeah, 60%. That's huge.
It's huge.
So it's like they're making it way more efficient.
Exactly.
But it's not just about the data, right? Yeah. Like they pointed out how that traditional best of N evaluation, it can be like kind of misleading.
Yeah, it doesn't tell the whole story.
Because an AI can get the right answer, but like
take all the wrong turns to get there.
Exactly, and we might not even realize.
We might think it's a genius, but it just got lucky.
So we got to look at every single step.
Every step.
And that's where like those benchmarks like Process Bench come in.
Exactly. They really put those PRMs to the test.
Make sure they're catching all those little errors, even tiny ones.
Yeah, they got to be thorough.
And like it's like we're holding these AI mathematicians to the same standards as human ones.
Yeah, we're not just looking for the right answer.
It's got to be logical.
It's got to make sense.
I feel like this deep dive has really like opened my eyes to how complex this whole thing is.
It is. It's really cutting edge.
And how much work goes into making AI we can actually trust.
Yeah, trustworthy AI is the goal.
And this is just math, you know? Imagine what this means for like all the other areas where AI is being used.
Oh, absolutely. Healthcare, finance, like you said before, research.
It's everywhere.
It's going to change everything.
This is like really just the beginning.
The tip of the iceberg.
So this brings me to my final thought for everyone out there listening.
Okay, shoot.
Like as these AI systems get like smarter and smarter,
yeah,
how do we even define like what it means for a machine to like truly understand something?
That's the million-dollar question.
And like, what are the ethics of all of this? Building AI that can think like us.
Yeah, that's a big one.
Like, it's mind-blowing.
Definitely something to think about.
So those are some things to ponder.
Yeah, chew on that.
Yeah. And as always, we've got those links to the paper and everything else in the show notes.
Go check it out.
So thanks for joining us on another deep dive.
It's been fun.
We'll catch you next time.